Let's solve some Leetcode hards. I haven't solved a lot of problems since a long time, so let's see how this goes. Where do I select the difficulty is hard. Let's also solve the recent ones. So for that, I need to sort this by question ID in reverse manner. Okay, so I don't think I have. Okay, this is the last solved problem, hard category. Cool, let's go ahead with one of them. Longest alternating subarray after removing at most one element and smallest integer with k1 bits. I'm just opening random. Count subarrays with majority element. What else? Find zombie sessions. Cool. Let's go over this problem 3836. You are given two integer arrays of length n and m. Integer k, you must choose exactly k pairs of indices such that they line the subarrays. For each pair ij, you gain a score of the product of those two integers. Okay, the total score is the sum of the product of all selected pairs. Okay, the constraints look small, so I think this can be done using dynamic programming. I hope the answer doesn't exceed maximum possible value in an integer. Is it mentioned anywhere? Maximum achievable score. We also have negative numbers. K is less than that. And the straightforward solution is to keep a track of index I in the first array, j in the second, and k for the length of the sequence that we are generating, and maximize it over all possible choices. What else? I'm not quite sure if this will. The maximum answer should be stored in a 64-bit integer because maximum product is 10 to 12, and sum over all of them would be like 10 to 14. So yeah, the constraint convey that indirectly. Cool. Let's go over the approach. So we have two arrays. Let me extract the lengths 10m. This dot n is a dot size, b dot size. What else? So we start at 0 0 for each of them, and we need to choose k elements. Let me write this function ij and remaining elements to choose. If I is greater than, let's also initialize a infinity. It has 10 raised to 18. If I is greater than equals to n or j is greater than equals to m, we need to show that this is an invalid choice, and since we need to maximize it, let's return a minus infinity from here. If remaining is 0, that means we have already constructed a sequence of exactly k indices. Then we should return 0 because this should contribute to the answer. And let's say answer is initialized. Answer for this state is minus infinity. We have a choice to maximize the answer with the product of elements at these two indices, which is we also need to store these two arrays. Let's make them vector of int ab, or I can simply pass them as a state here. Const vector of int a and const vector of int b. Let's maximize this a little bit. Cool. This should be of I times b of j plus go I plus 1 j plus 1 remaining minus 1 eb. And we have two more choices. Either we skip this particular element in index p and skip this one in index a. And since we are not creating a sequence, this should not increment. What else? Pass these two vectors a and b and return the answer from computation for this particular state. I think this should be it. Let me run this once. We haven't named this function. This should be calling the function. Terminate called after throwing an instance of invalid error while serializing long. But are we using long or const long infinite is correct? Let me take this as a global variable. And one more thing that I need to do here is if remaining is less than 0, but that won't happen since we are already considering this case. I think there is an integer overflow here. Let me handle that. Okay, do we have a line number where this is happening? A dot size. Okay, this is fine. Let me reduce it a little bit. Or let me just check what is the long bits C++. Should be 64 bits. Let's make this 10 to 16. Error while serializing long out of range. Why is the long range 2 raised to 53? Not quite sure. Let's make this 2 raised to 52. The cases are failing, but let me see what's the error. Output 6 expected. This is quite large. I is greater than equals to n, j greater than equals to n. Let me check if I'm reading the question correctly. We are expected to choose them in a subsequence manner, so this is fine. You gain a score of their products. Total score is the sum of the products of all selected pairs at an integer representing the maximum achievable total score. This looks fine. If remaining is 0, then we should terminate this, which is also correct. So this is choice 1. Take, and these are don't take. We are skipping the first index, then it should go to I plus 1, otherwise it should go to j plus 1. Let's also take this case where we are skipping both. Ideally, this should have been covered. I'm still not quite sure why this is wrong. So this is 3 into 4 plus 2 into 1. Sorry, 2 into 5. How did I get the answer of 19? Yeah, 5 B of G. Maybe I've taken this particular thing, but it's still not optimal. Max score NM A of I times P of J plus the remaining one. Okay, I think this case should be earlier, because if we move outside of the array index, and even if we have constructed all the elements of size k, still we are returning minus infinity, which is not the right thing to do. And this case is also redundant, so let me remove that. Now we just need to memorize this. I'll probably use a global map for this. So this should be integer, and let's make this underscore. And we have 100 as the max size, so let's make it 101 dp. And next thing is to initialize this int I0 is less than n plus plus j0 j is less than j plus plus, and there is k. K0 k should be less than equals to, because we are using one based indexing for this, this should be initialized to -1. And let's initialize answer with this particular state and check if answer is already computed. If it is computed, then return the answer. Otherwise, initialize answer with minus infinity. Testing this. This should be long. Cool. Let's submit. Time limit exceeded. This should not happen. Really, the time complexity is like 10⁶ operations considering dynamic programming. So why is this exceeding time? Most probably the tail cases. Let's try to run this test case and see if it runs quickly. Ideally it should. Maybe I need to perform some optimizations, or is this just some special case? So we have minus ones and ones, and key is 1. Why is this exceeding time? This won't even have as much. So this is like 100, I think. Okay. Okay, I think I understood. So I should not have used -1 as a non-visited state. Instead, I should use a Boolean visited, because -1 is also one of the possible answers. Let's do this. Visited as false and use visited here. Visited. We don't need to take it as a reference. If visited, we'll return DP. Otherwise, I will mark it as visited after the computation is done. And I also need to initialize. That is also not required. I can store this as, I mean, it's fine, whatever. TP of I, J, RAM is answer. Compilation error. This should be long, and this should be Boolean. Let's submit. Okay, looks cool. I'm not trying to squeeze in like the fastest solution in this. I'm just trying to get the problem solved. Nothing else. Let's move on to the next problem. Longest alternating subarray after removing at most one element. You're given integer array nums. Subarray is alternating if one of the following holds. First one is less, then it is greater, less, greater. Okay. In other words, if we compare adjacent elements, then the comparisons alternate between strictly greater and strictly smaller. You can remove at most one element from nums. Then you select an alternating subarray from nums. Return an integer denoting the maximum length of the alternating subarray you can select. Okay. This also looks like dynamic programming. You can keep it as a state. How many elements have we skipped? I mean, ideally, it's only allowed to skip 0 or 1. So if we skip one element, we need to check for an index I. The comparison should be like, I mean, it is a subarray. So the comparison for index I, if I minus 1 is skipped, should be done with I minus 2. Otherwise, I minus 1 as usual. Let's go ahead and implement this. Things will make sense after we start with the implementation. Let's initialize the size. We start with index 0 and we say that, okay, we don't necessarily start with index 0. We let's say best answer is, obviously 1 is possible, and array size is at least 2. So answer is at least 1. Done best. For each of the starting positions, I is less than, or what I can do is, if I'm skipping a particular element, then I can extend my search to the left and right of it. Yeah, that would be a better approach in my. Let's say I index I is skipped. We are removing at most one element. Cool. And the best answer could also be maximized by saying best is max of best, comma, we say go right from index 0, and the skipping part is already taken care of, so that should be handled, I think. But we are already checking for each of the elements, so it's better to do this here. So for each index I, I'm considering a subarray starting at index I and trying to find the best longest alternating subarray from starting index I, which is going to the right of index I. I'll write the go right function after this. So index I, this is saying that index I is starting from index I. From index I. And if you are skipping index I, we need to check the left answer as go left I minus 1 and right as I plus 1. And this will only happen if a of I plus 1. Let's solve both of these cases individually. So let's say if the left element is less than a of I plus 1, then we need to do some other thing, and if it is less than I plus 1, I need to do something else. Else if a of I minus 1 is greater than a of I minus 1, in both of these cases, we need to merge the answers from both the subcomputations, and we need to pass a different sign to these functions, go left and go right. So the sign is fixed as less than between these two elements. So go right should check that the next element to it has I plus 1 would be considered with I plus 2. Okay. So it should ideally check the next element is smaller. Let's say 0 is smaller. 0 means smaller, 1 for greater. And this one checks if it is, I mean, the terminologies could be interchanged. Let's get started with this first. What else? Let me also store this vector somewhere. This A is A, and integer go right, index I. For index I need to check. So ideally this should also check whether, I mean, this should include that we have considered this element in the answer, and this should consider that this one contribution means that we have considered this element in the answer. And best is max of best comma left plus right. Let's do the same thing. Copy this. Cool. Let's say boolean less. Let's use true or false. Okay, let's start with this first and we'll see. So we are at index I and we need to go to the right. And the condition that we need to check is if, and this should also have an answer associated with it. Index I is included only if the previous element is as per this sign. Or do I need to check for the next element? Yeah, I need to check for the next one. So if it is a less sign, I need to check if a of I plus 1 is less than a of I. And if it is greater sign, I need to check if a of I plus 1 is greater than a of I. Because you're passing I plus 1 here and already adding its contribution, we need to check the next element, which is to the right of it, since we are implementing go right function. So if this is the case, answer is 1 plus go right I plus 1, and the sign is flipped now. And these cases are mutually exclusive, so I don't need to maximize or do any computation or apply any aggregate function on this. So that should be taken care of. Cool. I haven't considered edge cases. So if I is greater than equals to n, I need to say return 0. Cool. Let's implement go left in a similar manner. Go left. If I is less than 0, we don't have an answer. And in this case, we are checking whatever index is passed here to the left of it. So if we are checking to the left of it, this should also be like this. We move to the left. I don't think we need anything else apart from these. So as per this parameter convention, we are assuming that we need to check the next element we navigate to with this particular sign. Okay, let's get back to this problem. Where were we at? We had implemented this go left. There is one more thing that I need to make sure is I minus 1 greater than equals to 0 plus 1 less than n. Let me use the same thing here. Cool. What else? Let's try running this. I think I also need to check this one. So this should be, I mean, check both, right? Left is less or irrespective of what is the sign. We need to do this for both of them. So let me do this twice. And one more thing that I missed here is I need to check the array bounds for this condition. I minus 1 greater than equals to 0 and that, and the same for this. And what else? I minus 1 and here it should be I plus 1. Plus 1 less than n. Compilation error. Okay, we got the answer wrong on one test case. Expected 4. I think there should be 1 plus go right from index I plus 1. A plus 1. Submit this. I'm expecting this to time out because this is order n square currently, but we got wrong answer. Cool. For this case, what are we missing? Ideally, this should be taken care at this particular condition. Okay, why did I miss writing I plus 1 here? We are wrong again. I think this should be I only. Let's try this test case. Submit. Wrong answer. Output is 3, expected 2. This will be a little hard to debug, but let's see. Let me see if this 3 is generated from which condition. Comment this. Okay, so if I comment out this part, I'm getting 3 from there. So most probably it is like, so if I'm skipping this, it is checking. Let's do for all the cases. So if this element is skipped, index I, and we don't have anything, so only this 2 skips are allowed. If this is skipped and a of I minus 1 is greater than a of I plus 1, in that case, I need to check if, I think I should just try flipping these conditions. One of them would give me the correct answer. Okay, cool. This is what I expected. Now let's memorize this. Let me explain why this is timing out. So if you check this particular, I'm calling this function from a particular index n times for each of the starting elements. So this function itself is order n time because it goes over all the elements either to the left or right hand side of the parameter index. So we need to memorize it. Let's do that. Let's not call it DP because there is no dynamic programming here, just memorization. So it's like saving a state and avoiding recomputation. I'll probably use a global variable for this. So integer cache left, and what is the maximum size? 10⁵. Okay. Constant 1e5 plus 1, and I need to reset this. I0 I is less than n, I plus plus cache left of 0i cache left of 1i is minus 1. Okay, so this is initialized, and now I just need to check. Let's do it in this manner. Cache left of less of I. If it is calculated, return it. Otherwise, initialize it with 0. Copy this. Let's run the test cases. Cool. Okay, so we got the answer right. That's it. I'll probably upload more solutions to hard Leetcode problems, solving them live. That's it for this video. Thank you.